Hi friends, we all wonder about human afterlife. Today we shall learn more about what happens when a star dies. In other words, the cosmic afterlife of a star. Let's dive in. The cosmic afterlife of a star is determined primarily by its initial mass, which dictates whether it ends its life as a gentle white dwarf, a super-dense neutron star, or an inescapable black hole. The matter from these dying stars is often recycled, forming the building blocks for future generations of stars and planets. Here is a breakdown of the stellar afterlife decoded by mass. Low to medium mass stars like our sun stars up to about 8 times the mass of the sun follow a less dramatic path to the end of their lives. Let's understand it. 1. Red giant phase. After exhausting the hydrogen fuel in their core, these stars expand dramatically to become red giants. During this phase, they begin fusing helium into carbon in their core and hydrogen in a shell around the core. 2. Planetary nebula. Once the helium is depleted, the core contracts, and the star becomes unstable, expelling its outer layers into space. This forms a beautiful, expanding shell of gas and dust called a planetary nebula, which has nothing to do with planets. 3. White dwarf. The remaining core is an incredibly dense, hot remnant called a white dwarf, primarily composed of carbon and oxygen. It no longer undergoes fusion and slowly cools over billions of years, eventually becoming a cold, dark black dwarf, though the universe is not old enough for any black dwarfs to exist yet. Let's see what happens to the massive stars. Stars significantly more massive than the sun, generally more than about 8 times its mass, end their lives in a cataclysmic explosion. Massive stars may undergo following changes. Red supergiant phase. These stars swell into red supergiants and are hot enough to fuse progressively heavier elements, from carbon all the way up to iron, in a series of concentric shells. Core collapse and supernova. Iron is the most stable element and its fusion absorbs energy rather than releasing it, so once an iron core forms, the star loses its internal pressure balance against gravity. The core collapses within seconds, creating a massive shock wave that causes the star to explode in a brilliant supernova. This explosion can briefly outshine an entire galaxy and is responsible for creating and scattering most of the heavy elements in the universe into space. Stellar remnant. What is left behind depends on the remaining core's mass. Neutron stars. If the core's mass is between approximately 1.4 and 3 solar masses, the immense pressure forces protons and electrons to merge into neutrons, forming an incredibly dense neutron star. A teaspoon of neutron star material would weigh billions of tons on Earth. Some rapidly spinning neutron stars are observed as pulsars, which emit beams of radiation. Black hole. If the core's mass exceeds about 3 solar masses, not even neutron degeneracy pressure can stop the collapse, and it continues to shrink into an infinitely dense point called a singularity, forming a black hole. Its gravitational pull is so strong that nothing, not even light, can escape its event horizon. In essence, a star's death is not an end but a transformation, where the material is either locked away in a dense remnant or recycled to forge the next cosmic generation. Like we say, energy is only transformed form to another, but never destroyed. Likewise, everything in the universe is transient. Thank you for watching. See you next time.